at the reference, we call it V1. The voltage of the node B is given with plus at B, minus. This is material, basic material from chapter 2. Let's call it B2. If I assign a voltage across, doesn't matter. Let's say plus at the A side, minus at the B side, and call it V0. According to KVL, what is V0? This is the thing that you should know from the first part of the course. Aguilar, are you here?
Yeah.
Okay, what is V0? Just use KVL for this loop for me.
V1 plus V0
V1
plus V0.
plus V0?
Yeah. Minus V2 equals 0.
Okay, Alejandro, do you agree with this?
It would be V1 plus V2.
Then what? What about V0? We just had exam 1. This is just a KVL for this loop. No, this is Alejandro.
Yeah.
Okay, what is V0? Where should I put V0?
Plus V0.
Oh my God. Amador. Amador?
Yes.
Henry, do you agree with any of them?
No, I got a little confused because there's no actual loop that we're looking at.
This is a loop. Loop is a loop. It doesn't have to be physical loop. It's a loop. Go around the loop and write V. Did I say KVL should be only applied to physical loop? Loop is a loop. You go start from here and return to here.
Okay,
Isn't it this a loop? Yeah. Okay, for this loop, what is KVL in your opinion?
V1 equals V2.
So what happens to V0? V0 is not along your way.
Yeah, so V1 plus V2 equals V0.
Argandona.
I'm here.
What's KVL?
Wouldn't it be V1 minus V0 plus V2 equals 0?
I did a horrible job in this class. I think that's my fault. So far, nobody knows KVL. Beltran. Jesse Beltran, are you here? Jesse Beltran. I'll be super, super restrict about no shows from now on. Beltran?
Yeah, I'm here. Sorry, my mic wasn't working.
Okay, what's KVL here? Apparently, so far, my conclusion is I'm the worst circuit teacher. Nobody knows KVL. Okay, you tell me, what is this? What's KVL here? So if I go through the whole class and nobody can give me KVL, I have nothing to say. I don't know.
It's V1 equals to V0 plus V2.
Thanks, God. Those of you up to Mr. Beltran, what are these? When did I say, I mean, how many times should I repeat? You go around the loop. Voltage rise equal to the voltage drop. Why you are saying V1 plus V0? Just move. It's voltage rise, voltage drop. Why do you have the same sign here? Can somebody explain? Or somebody said V1 and plus V2. Voltage rise, voltage drop. Somebody said V1 plus V2 equal to V0. V1 and V2, they have opposite voltage arrangement, polarity arrangement. What is so difficult? What is so difficult to understand that? And then they say, when I ask several times, I'm intimidated. I mean, this is just, we finished KVL. We're supposed to know KVL in and out. Isn't, how many times did I say that voltage rise equal to the drop plus drop? Again, let me know, what is so difficult about this concept? It's not electromagnetic, it's not math formula, it's not integral, it's not differential. It's just the voltage rise equal to the voltage drop in any direction. If you want to move in this direction, rise, drop. So V0, V2 are added on one side and the one with the opposite polarity on the other side. Is it my fault? I think so. I think I haven't done my job. But I don't know how to do it. Sorry. I can repeat 100 more times. Summation of voltage rise equals to summation of voltage drop. Okay. Now, let's continue. Bernal.
I'm here.
Okay, so V0 is equal to, according to the correct one, V0 is equal to V1 minus V2. Can you see a pattern here? V0 equal to V1 minus V2. Can you make it like a shortcut observation pattern here?
Well, we notice the left side is always going to be the rise and the right side is the drop. So maybe there's always
No, not left, right. You cannot use left, right, because here I put plus on the, what about if I put my plus here and minus here? Then what is V0? Okay, you tell me if I have plus to the right and minus to the left, then what is V0? Without writing KVL.
that would be V2 minus V1.
Perfect.
So we can see that the plus side is always going to be
Yes.
adding and the minus side is subtracting.
Yes. A voltage across between two terminals, voltage across is always equal to the voltage at the positive side with respect to reference minus the voltage at the negative side with respect to the same reference. That's called voltage across. Okay? Any questions?
Yeah, can you repeat that one more time, Professor?
Yeah. The voltage across means between two terminals, is always equal to the voltage at the positive side of the terminal with respect to reference, minus the voltage at the negative side of the terminal with respect to reference. So for example, let's go, instead of repeating, let me give you numerical example. Castaneda.
Yeah.
If this is a reference, and I have plus or minus 4 volts, and I have plus or minus 6 volts, and then I have plus here, minus here, call it V0, without writing KVL. That's the whole purpose of shortcut. Based on this observation, what is V0? One shot, one formula, one quick writing. What is V0?
It's 6 volts minus 4 volts.
Minus 4 volts?
Or plus 4 volts.
Minus 4 volts.
Yeah.
So it's the voltage at the positive end minus the voltage at the negative end. This is called voltage across. This is a result of KVL, but you don't have to write KVL. Any question here?
Just a quick question. Shouldn't the V not be negative?
No, it's the voltage at the positive side, which is 6 volts, minus the voltage at the negative side of R, which is minus 4 volts. So it's plus 10. Why it's negative? Why do you see it as negative?
Because it's going across negative. It's gonna be
What is the shortcut?
rising. It's gonna be rising from negative to
No,
positive.
no,
V
the
naught.
point, okay, the point here, okay, you want to write KVL, that's a rise or fall. But when I give the shortcut, then you don't have to think about rise or fall.
Oh,
If you
okay.
want to think about rise or fall, it's the same answer. It's a voltage rise, 6 volt, voltage drop, V0, voltage rise 6 volt, voltage drop, V0 plus voltage drop. It's the same number.
Thank you.
If you want to write KVL, but I don't want to write KVL. This is a result of KVL. It's the voltage at the positive end minus the voltage at the negative end. Okay. Now let's continue. Castro,
Hey, what's going on?
I'm asking you what's going on now. Okay. Go back to this V0. Based on polarity, what's the direction of the current according to passive sign, from left to right or right to left?
Passive. That always kind of tripped me out.
Why?
Hold on. Passive would be right to left and left to right. If you
Left to-
with
So
the
passive sign convention.
left to right.
Okay, correct. So what is Ohm's law now? You assign a passive sign. So what is Ohm's law now? What is Ohm's law here?
V naught over R.
Correct. But V naught is equal to what? V1 minus V2 over R, right?
Yeah.
Okay, good. Claire.
Here.
Okay. Here is the foundation. Main observation of nodal. I'm going to erase everything. I'm going to erase even V0. I'm going to erase even the current notation. Okay. I want to write the current. Actually, let's put I again, and then I'll see. Okay, I want to write I. I want to bypass Ohm's law. I want to bypass KVL. You have element between point A and point B going from A to B. Pay attention to the direction of the current. It's going from where to where? A to B.
Okay.
This current, Ohm's law, is volt divided by Ohm. What shortcut pattern you observe? A current goes from A to B. What's the shortcut pattern according to your observation? I erase polarity, I erase V0, everything. I just kept the current.
That's gonna, I guess, the voltage rise minus the voltage drop over R.
There is no rise or drop. There is no, I erased it plus or minus.
Okay. I was looking at the V1 and V2. I'm sorry.
What is V1? V1 is the voltage at node A.
Right.
What is V2? Voltage at node B.
B.
I goes from A to
To
B.
B.
So what is your shortcut observation? Going from side from to V2. From A to B. The voltage at A with respect to reference minus voltage at B with respect to reference divided by R. This observation bypasses KVL, Ohm's law, everything. It's based on KVL, Ohm's law, but you bypass everything. One shot. Okay. Let me see, we have 10 ohm. We have minus plus 2 volts plus minus 6 volts Okay. Now let's go to
Professor, I have a question.
Mm.
What method is this considered again? Like
method. This method, I'm no name for this method yet. I'm just saying the current going from A to B. It's a voltage at A minus voltage at B divided by R.
Okay, understood. Thank you.
Yeah. Okay. Let's consider this problem. Contreras.
Amir.
Shortcut. I don't want to write KVL. I don't want to write Ohm's law. One shot. What is that?
It is gonna be. Is it gonna be 6 volts, 6 minus 2 over 10?
Correct, except one problem. Nelly, can you detect that problem?
It's positive. Instead of negative, it's positive.
Yes. Notice that if you want to use this shortcut, the terminal voltages should have plus in front of them and minus as reference. In this case, it's opposite. So what you do is first switch polarity, change this one to minus, and then apply. Then it's 6 minus 6 minus 2. Voltage at the current goes from 6 volt node to this node. So it's the voltage at this end, 6 volt, minus the voltage at this node, provided that plus is at this node, which is minus 2 volt, divided by 10. Textbooks, they don't show nodal based on this shortcut. That's why students, they always remain confused. I cannot make it more systematic than this.
So do you always switch polarity?
Yes, yes. This is one time that you switch polarity to make sure that the reference has minus, node has plus. Even if you end up with negative number, that's okay. Because you want to use shortcut. Remember, rather than, if you don't know the shortcut, what's the procedure? You have to write a KVL and you have to write Ohm's law. You bypass both of them. One shot, you can write current. Any question about this observation?
Yeah, so you go from you add the plus side minus the minus voltage.
No, you pay attention to the direction of the current. The current goes from towards starting end, right? The voltage at the starting point, 6 volts, minus the voltage at the end point.
Okay.
That you switch minus 2 volt divided by 2. So anytime you want to use this shortcut, notice that I did not put any polarities here. So I'm just paying attention to the direction. Current goes from A to B. So it's voltage at A minus voltage at B. If the current goes from B to A, then it's voltage at B minus voltage at A divided by 2. But the observation that the student said about plus 2 is the fact that notice that when you have terminal voltages, you must first, before you do anything, make sure that you have plus at the terminal and minus at the reference. Original problem gave you minus here, plus here. What I did is I switched the order plus minus minus 2 so I can use the shortcut. Current goes from 6 volt toward minus 2 volt. 6 minus minus 2 divided by 2.
Okay, got it.
Any question?
Can I copy it down for a little bit real quick? Sorry.
Sure, no problem. I also explained in the handout, but that's fine. If you need time to copy something, let me know. As I said, maybe it's a good thing the pen is now has a huge font and I cannot bring it back to the normal font. Something has happened to my screen. Okay. Now, so this is the foundation of node. Okay. Based on this observation, I'm going to explain nodal analysis. You don't have to write the whole thing. I mentioned all in my handout. Nodal is based on the following steps. Number one, you must have a reference. Either you assign or you can choose any point as a reference, or problem gives you the reference. Number two, you will specify all essential nodes. What is essential node?
Where three branches connect.
Three or more branches. Okay, you specify all essential nodes. Assign node voltage to essential nodes with plus at the node and minus at the reference. Okay. Number three, assign current directions to all passive elements. Any direction. And don't label, just direction. Assign current direction to all passive elements. Any direction. I'll practice on several problems. I practice on many problems. Last thing is, write KCL for all essential nodes. Then there is one special case that we discuss it later, but these are the main steps. Okay, don't ask any question yet because I want you to do it. I put a circuit from this point, I'll show it by circuit. I use circuit from my handout, and then I'll use many more circuits from textbook. First, I'm going to start with a circuit from my handout. As I said, I'm going to involve this class several times. This is an important method, trust me. With this method, you can handle, you can open any book in circuit, go to the much later chapters, and write equations. There is no restriction, there is no limitation. You can have dependent source, you can have independent source, you can have multiple loops, doesn't matter. The point here is you can have perfect mathematical equation. Of course, solving equation, I know that's a math one, but you have a perfect model, circuit model. So let's practice the guidelines. These are steps. I'm going to use example from my notes. Consider the following example. I'm going to involve this class. Even with my face-to-face, this was one topic that I had to involve everybody. Going around and involving everybody. So it's not just for taking attendance, but I want you to really understand the concept. Okay, let's go to Estrada.
Here.
Okay, this is a circuit. How many? We have two independent sources. My question is, can you combine these two sources?
No.
No, because they are not in series or parallel. Can you combine any resistors?
I think you can combine 6 and 3.
Why?
Because they're, oh wait, actually,
How can you combine 6 and 3?
No, you can't combine that.
You cannot. So you cannot simplify anything here. Since you cannot simplify anything, can I use voltage division or current division here?
No.
No, because I cannot reduce to. Remember, for voltage division, current division, I couldn't give you easier circuit than ones I gave you in example. It's just single loop or single node. In this case, we cannot do anything. Okay. So this circuit is given and they ask you some question. And maybe the question is find I. The problem is asking you to find I. So the following circuit is given. Find I. Okay. I cannot use voltage division. I cannot use current division. Jose Garcia Sandoval.
Yeah. I'm
Okay,
sorry
so-
for the background.
No, it's okay. If they give you the circuit and they ask you to find I, what do you do? How do you do it? I could give you this problem in the exam because you already have knowledge to do it from chapter 2. But basically what you do in order to solve this, I mean, from chapter 2, remember the claim was with KVL, KCL, Ohm's law, you can solve any circuit. So if this circuit is given, I could easily give you this one. And I was tempted to give you this circuit so you can use also as a background for chapter 3. But how do you solve this problem? I mean, circuit problem.
Without using KVL and KCL.
No, with KVL, KCL, I mean, the knowledge that you have gained so far, I haven't started any new lecture yet. So, I mean, any new method yet. So based on your knowledge, if they ask you to find I, how do you do it?
I would use KVL.
How many KVLs?
It would be so two.
So what? Yeah, you assign, for example, don't write anything because I'm not going to use this method, but I'm just showing you the procedure. So you call this voltage V1, V2, let's say V3. So you write the KVL equation for this loop, 3 volts equal to V1 plus V2. You write the KVL equation for this loop. So it's V2 equal to V3 plus 8. And KCL. What is your KCL? You have to assign a current here, maybe I1, I2. Then what is the KCL? I1 equal to I plus I2. Okay. Then you substitute V1 according to Ohm's law as 6I1 and V2 according to Ohm's law 3I. And from here, V2 is equal to 3I equal to V3 is equal to 2I2 plus 8. And then you have I1 equal to I plus I2. Okay, look at the KVL, KCL. You have 2 KVL equation, 1 KCL equation. I1, I2, I. You end up with 3 equations, 3 unknowns by using KVL, KCL also. Anybody has any question here?
Professor.
Yeah.
In this case, it would have helped to do the outer KVL, like only the outside.
It doesn't matter. You need 2 KVL.
Oh, okay. We already got it. Never mind.
Yeah. You need 2 KVL and 1 KCL. And the reason is you have 3 unknown currents because you are applying current voltage paired to each passive element. And you have 3 passive elements. So you eventually need 3 equations. You are perfectly fine. You can write the outer loop. But then you have 1 outer loop, 1 inner loop, 2 equations, and 1 KCL unknown. This is the exact method. KVL, KCL, Ohm's law. Any question? Okay. Yeah, go ahead. Your name? What's your name? Yeah, I called your name and you answered the question. Really? I remember I called Bentley, but maybe somebody else answered the question. That's okay. Okay, that's okay. No problem. Because I don't see the screen from here, so that's why. Okay. Any question here? Now, the point of nodal, the shortcut methods that we are starting today, is I don't want to write 3 equations here. And notice in this case we only have 2 loops. We have many cases that we have 4, 5 loops, maybe 5, 6 nodes, and then you end up with 5, 6, 7 equations, unknowns. And also in this case, everything is given in design problem. There are some parameters that are given. So this is not an easy mathematical follow-up if you have 3 equations to unknown. So you want to avoid writing 3 equations to unknown. Okay. That's the whole point of nodal. So I'm going to use nodal and I solve this problem with 1 equation.
Are you going to use the bottom of the circuit as your reference point?
Okay, I haven't started. I mean, for KVL case, you don't need reference. However,
No, what I'm saying.
Yeah. Because I'm going to start now the guideline. You're a little bit okay. Now I want to use nodal. Okay, guideline number 1. I mean, before guideline. When you start nodal, ignore the question. Nodal is general math. Actually, even remove the question. Redraw the circuit without the question. Nodal is independent of the question. If I ask you to find I, if I ask you to find V1, V2, anything, you use the same method. So at the beginning, start nodal, ignore the question. Okay. Let's go to Jose Garcia. We are starting now. Step 1 in nodal is choose a reference. Somebody just mentioned. It's up to you. But I mean, naturally, when you look at the circuit, what is your choice of a reference?
Would usually to 3 volts.
No. Choose a reference node.
Oh, reference node.
Yeah.
In the middle of all the resistance. Top middle.
Let me ask class, is that a good choice?
No.
What is a good choice? Usually the bottom one. No, don't even think about super. The bottom one. Usually the bottom, when you have the negative of the sources connected or the most number of elements connected to, it's a good choice. However, when the student said this node, that's perfectly fine, but you make it a bit more complicated later. But you can choose any point, but this is a good choice for reference. So this is going to be my reference. Okay, Gonzalez. Except for reference, identify all essential nodes except for reference. How many other essential nodes do you observe here?
Three, four.
What is essential node? Carl, how many essential nodes?
I only see 2.
Which 2? I mean, except for reference.
Oh, just one.
Reference node is a node that you have 3 or more elements connected. Let's call it node 1. You can either use alphabetical A, B, C, D, or numbers 1, 2, 3. Hermosillo.
Yes.
It says choose, find essential nodes, and assign the nodal voltage.
I believe that the voltage that the 3 volts and the 8 volt is fine now because.
No. I mean, 3 and 8, exactly. You have one node and you assign essential node. V1. The guideline says V1, V plus, and minus. You don't even have to show it plus or minus. Just call it V1. Don't mess up your circuit. However, yeah, okay, so you have essential node, you assign a nodal voltage. A guideline number 3 says assign current direction only, don't label it. Only passive elements. How many passive elements do you have? 3. So 6 ohm, 2 ohm, 3 ohm. What direction do you like? Do you want from, I mean, don't, in this case, this is a good thing about here. Don't even have to worry about passive sign, non-passive sign. You choose. Do you want from left to right, right to left, anything?
Right to left.
What about 2 ohm? You choose.
Same. Right to left.
What about the 3 ohm? Going up or down?
Let's do it down.
Okay. Don't label. So you select essential node, you select reference, identify essential node, call it V1, and then assign current to passive elements. Okay. Now let's go to the difficult, not the difficult one, but the equation one. Step number 4, Aiden Lee.
Here.
You have to write the KCL equation for all essential nodes. In this case, we only have one equation. Okay. When you write this KCL equation, have a quick assessment. When you look at the circuit, essential node, we only have node 1. How many currents entering, how many leaving node 1? Have a quick assessment.
There's 1 entering and 2 leaving.
Okay, 1 entering, 2 leaving. Entering equal to the summation of leaving. That's KCL, right? Let's start with this entering one. However, I don't want to write Ohm's law, KVL. Remember previous discussion I had? What is this current? Current passing through 2 ohm. From where to where? The current entering goes from where to where?
The 8 to the 3.
8 to 1. 8 to 1, right? This is the direction of the current. So what is this current now? What is the voltage at this end from? With respect to reference, what's that voltage? What's the voltage of this point with respect to reference?
8.
Minus, what is the voltage of this node with respect to reference?
3.
This node, I'm not talking about this node, I'm talking about this node.
Oh, V1.
Divided by Ohm's law. 8 minus V1 divided by 2 ohm. That's the current entry. Nelson Leon.
Yes.
Current leaving. Use the same method. What is this current?
It will be V1 plus 3.
Y plus voltage at one end minus the voltage at the other.
Sorry, minus 3.
Divided by
6.
6. Macias. The other current leaving, going from where to where?
From 1 to the reference.
Reference is 0 potential, so it's what?
So V1 over 3.
Minus 0 divided by, you don't have to write minus 3, but I just want to, this is your nodal equation. One equation, one unknown. Okay. The next step is to solve this equation. Solving is math. Solving the equation is the math part. Okay, Melendez?
Yes.
How do you solve this equation? This is like a regular algebraic equation. How do you solve it? You have only one equation, one and one. How do you solve it? What do you suggest?
I would suggest first getting this same denominator.
Yes. That's very important. Nodal always gives you fractional form, denominator. Get rid of denominator. You can use any method, but this is just the math suggestion. So take the common denominator, multiply both sides by 6. In this case, you have a common denominator. Otherwise, multiply by common factor. Point here is get rid of the denominator. So multiplying by 6, you get 3. It's 24 minus 3v1 equal to v1 minus 3 plus 2v1. Put all these together, so you have 1, 2 plus 1 is 3 plus 3 is 6v1 equal to, moving this 3-1 and then 3 to this side, equal to 27. v1 is equal to 27 divided by 6. So, so you find it.
Can you explain V1 minus 003 one more time? Sorry.
Okay, this current, this is the current. At this point, you can ask, I mean, because you have, what is this current? This current goes from, initiates, it starts from V1, right? And ends at reference. So it's the voltage, you have to pay attention to the duration. Voltage at this end, which is V1, minus voltage determination point, 0 divided by 3. Current is volt divided by 1. So it's V1. This is the current. V1 minus 0 divided by 5. Voltage at one end minus voltage at the other end divided by resistance. Okay. You find nodal voltage. Once you find nodal voltage, go back to original circuit. Put the solution back. Put the question back into the circuit. Okay, Mendiola. The question was to find I. After I find my nodal voltage, I go back and answer any question about the circuit. Any question you have about the circuit is related to V1. You don't have to write KVL, KCL, nothing. If I go back to my original circuit, the question was I, for this case. How I is related to nodal voltage, Mendiola? Antonio Mendiola, yeah. The question is I. How I is related? Now I want to answer the question, the problem. How I is related to V1?
Almost lost.
It's equal to what?
Is it V over R?
V1 over what?
The resistance.
Which is what? Don't you see it? It's give me number. I mean, isn't it obvious? This is I passing 3 ohm. Isn't it voltage divided by 5 ohm?
Yeah.
Okay, you can answer. Now, Paul Monge.
Yeah, here.
Okay, I want you to challenge me. Go to this circuit and ask any question about the circuit and see if I can relate to V1 or not. The point here, that's the strength of nodal. Once you find nodal voltage, you can ask any question about the circuit. Ask any question about the circuit, any voltage, any current. You choose.
You ask any voltage.
I mean, you choose. What I'm saying is just choose anything you want to know about the circuit. Like, you choose either voltage, current, anything.
So, like, I could ask, like, what's the current at 6 ohms?
Okay. The current from left to right or right to left? Which one?
From right to left, since the arrow is going that way, anyways.
No, you don't have to. Actually, what I'm going to do, I do the opposite. Let's call it I0. Okay, how I0 is related to V1? If you want to answer this question. I0 is the current passing through 6 ohm, going from here to here. From 3 volt to V1. So how do you write I0?
It'll be 4.5 over 6.
4.5 over 6? Is the voltage across 6 ohms 4.5?
I would say.
Moreno, what is I0? It's an element across between two terminals. Moreno,
Yeah, here.
what is I0?
V1 over 6.
Is the voltage across 6 ohms V1?
Oh, no, my bad. It'll be, yeah, 3 over 6.
The voltage across 6 ohms is 3 volts.
Would it
I just said,
V1? 3 volts.
I spent 30 minutes of the previous, the starting part of the lecture talking about the voltage across between two terminals. What did you say? Somebody just mentioned?
3 volts minus V1, positive minus negative.
There's no positive, negative. It's going from 2. It's 3 minus V1 divided by what?
6.
You cannot just say 3 minus V1. That's volt. Volt is not equal to amp. Volt divided by ohm. Okay. Do you have any questions? Do you have any questions?
Professor?
Yeah.
With the passive elements, only the directions, but like once we assign the voltage right there. What did that help? Because you said that we don't have to assign polarities for this method.
For this method, for passive element, you assign current only. And you only apply voltage to node. Essentially, that's it.
Oh, so when we're connecting the essential node to ground, that's when we write a voltage direction only for that?
Yes.
Sorry. Okay.
Polarity, yeah.
Thank you.
Okay, let me do one more problem for the time. I went up to Portugal. I may not have time to involve the whole class, but I'm going to continue next time. As I said, this is one topic. Even if I go slow, I have to involve everybody. Let's say you have 4 ohms, 2 ohms, 12 ohms. Okay. This is also in your. This is in the handout. 4 ohms, 2 ohms, 12 ohms, 6 and 9. Problem is asking about plus or minus 50. At this point, please answer voluntarily because I don't have time, but I'll continue next time with the rest of the class. It's okay. Usually, if you're not involved, I may not be able to finish the whole roster. Okay, in this case, what is a good choice for reference? Anybody?
The ground.
First of all, you forget about the question. Don't mind the question. Forget about it. How many essential nodes? Let's do it quick.
2.
Okay, this is my challenge. It's 10:33. We finish at 10:40. In 5 minutes, we finish this problem. Less than 5 minutes. Let's finish it in 5 minutes, except for the math part. Just the setup. How many essential nodes?
2.
V1, V2. You don't even have to show plus or minus. It's granted that it's plus or V1 for the reference. How many passive elements? 3. Current direction. In order to speed up, I'll do it myself. You can choose any direction. Okay, 2 KCL. What is KCL 1? Node 1.
14 minus V1 over 4.
Okay, this is equation. KCL is equal to what?
It's equal to I1.
There is no I. There is no I. This is
0 over 2.
What about this one? What's the KCL for 2? KCL for 2, 6 amp is 10, then 12 amp. V2 over 12 is leaving. What about this branch? Any thoughts? 1 minute. The branch is causing problem. Why it's causing problem? Again, 1 minute. Why it's causing problem, this branch?
It's an independent source.
It's an independent source. Remember, the guideline says do not assign current to independent source. It's not zero. This is not zero. You cannot assign. I mean, you just leave it as unknown. You don't want to add to unknown. Problem says only assign current to passive elements. So what about this branch? Branch is giving you problem. Do you remember the concept of supernode? If the branch is giving you problem, bypass. So this is your supernode. So write KCL for supernode. Now this supernode, you don't see the inside. From outside, you have 1, 2, 3, 4 connected. How many entries? 2 entries. 14 minus V1 divided by 4 entry. 6 amp is also entry. How many leaving? V1 divided by 2, V2 divided by 12, V1 minus 0, and V2 minus 0. One equation, 2 unknowns. That's not enough. How do you get the other unknown? I still have 2 minutes before 10:40. That was my challenge. This is one equation. I bypass the source. Anytime a source is connecting to nodes, bypass. If it's source between node and reference, that's fine. But if it's across, bypass it. But I end up with current entering, leaving, and entering. I have one equation, 2 unknowns, V1 and V2, because I have 2 essential nodes and they're not the same. How do I get my third equation? I mean, second equation. You have to get it from the bypass element. How bypass element? This is 4 volt source. This is a 4 volts source. The problem gives you as 4 volts. This is 4 volt source. How this source is connected to, it's related to V1 and V2. Anybody? It's a voltage across. I gave you guideline at the beginning of my lecture. If you have a voltage across, what's the voltage across?
V1 minus V2.
Why V1 minus V2? Why not? V1 is connected to the negative polarity. V2 is connected to positive polarity. What was the guideline?
It's V2 minus V1.
Equal to what? It's a source, independent source. It's given. It's equal to what?
4 volts.
You have 2 equations to unknown, and this is easy equation. At this point, when you have your equation, go back and read the problem, the question in the problem. Put the question back at this point. Once before you solve anything, go back and put the question. The question is your original problem. The question is asking about. Plus or minus V, the voltage across 12. What is V? V is the same as V2. The question in the problem V is the voltage across 12 ohm. This is the question. V is the same as V2. So from these 2 equations, you don't need for V1. So in mathematics, if you don't need any variable, get rid of it. So from this equation, V1 is equal to V2 minus 4. Take V1 substitute back here and here. Get rid of denominator and solve it with V2. And V2 is equal to the answer. This problem is also in my handout. First page. I wanted to explain. That's pretty much it. That's how we do more problems with independent source, until this. But that's basically nodal analysis. There is no weird case, there is no special case. You don't even have to simplify. Sometimes sometimes even if you forget to, for example, combine current sources or voltage sources or series parallel, that's fine. You can just take the first draft circuit without simplification and right away apply normal. This equation, if I don't use nodal and if I just use KCL, KVL, Ohm's law, I end up with 1, 2, 3, 4 equations for unknowns. 4 equations for unknowns. But with nodal, I had practically 1 equation. Why? Because the second equation is easy. And you just substitute. Any question here? And notice we did it on time by 10:40. I promise that you can solve this problem in 3 minutes, 4 minutes. Any question here? If you don't have a question, that's the end of the lecture. I'll continue. Next time, if you have any question, you can say it again. Ask question about this problem. Yeah.
I had a quick question, Professor. When you chose the supernode, I remember prior you said that sometimes you can choose to skip certain elements.
Okay, in this case, remember, supernode is a general constant. You can skip anything. However, for nodal, you don't want to skip your circuit. You want to skip the branch that is giving you a problem. Because this branch, I don't want to assign any current. There is a current for this branch. But that current really is unknown that I cannot use Ohm's law. Notice that if I have any voltage source, let's say plus or minus, if I assign current, the current and voltage are not related because there is no resistance here. So current always remains as unknown and adding to unknown. I don't want to do that. So the voltage source connecting across is causing problem in my nodal process. So I use supernode, and nodal is based on KCL. Remember, you can bypass KCL. Supernode is a constant used for KCL. So I can bypass based on KCL. I can choose a supernode, but not any supernode. This is a supernode that I'm bypassing the branch that is causing problem. Branch and all the lines that's connected and nodes connected to the branch. It's part of your inside supernode. And then from outside you have 1, 2, 3, 4 branches. And I write KCL to 4 external connections to the supernode.
Alright, that's why then. I understand how you did everything, but the why was a little bit unclear until you just explained all that right now. Because there's 2 essential nodes right there, and then in the guidelines it says that there's an independent source too, right? We can't have. So that makes sense why you circled that.
Yeah. Any other question?
Thank you, Professor.
So outside of the tutoring hours, is there any way we can like schedule hours this week to get help?
No. With online, I don't have office hours. I cannot have a Zoom office hours. I'm teaching 4 classes. I cannot do that. I can't afford the time to do that because if I do it for 1 student, I have to do it for the whole class. So you can ask my email any questions, or you can ask at the beginning or the end of the class lecture.
Okay. Alright, yeah, because I also have class during the tutoring hours, so I can't make it.
I'll ask tutor if they can come up with a different time. What is your preferred time? I mean, in general, I just have some idea. What is a good time for tutoring? As I said, I cannot impose it, but maybe I can suggest.
I will probably have to get back to you on that. But generally Mondays and Wednesdays. I mean, either day, just different times of the day.
Yeah. Okay. I'll ask tutor to see if there is any arrangement. I mean, if you can arrange a different time. Okay. Any other is any other question? Yeah. Okay.
I have a concern, but it's not about this. It's just something like not private, but it's regarding the homework. So I don't know why, but whenever I send you an email, it says the message is blocked. So I've been sending it to your other email that exchanged one instead. The one that you sent.
University email, they are not blocked. I mean university, because I'm using my CalState LA email. Private email has a block thing, but the CalState LA email, they don't have any block situation. So I really don't know why. Because what's your last name?
My last name is Samai. So I just been sending it to the one that you've been sending us emails.
Yeah. I do receive your homework. I think. Did you receive any note from me that missing homework or anything?
No, I haven't.
So probably I received it. You get that? No, I apparently I'm receiving your email.
Okay, awesome. I just wanted to make sure.
Yeah. Because if I don't receive your homework, I let you know. I send notification to students.
Okay.
If I don't receive the homework. So if you haven't received anything from me, it means that I'm receiving it. I don't know why you're getting it. No.
Okay. Yeah, I tried to, when I was doing the exam, I tried to forward it to you as well, and it didn't let me, so I just told it to the proctor, and he said, oh, okay, well, next time just get it ready. I'm just hoping that next time it doesn't block you when I try to forward to you as well.
No, I think everything is fine. So far. I mean, let me check. Yeah, your work is fine.
Okay, awesome. Thank you so much. I appreciate it.
No problem. That's okay. Any other question? I have another class, but do you have any other questions? Please just check these two. Yeah, go ahead.
I actually had a similar question now that you mentioned it. I've been sending it in the exchange email too, but I haven't gotten an email saying you haven't gotten it, so.
Yeah, maybe the problem is exchange. Maybe if you just say LTAP please attach with LA.edu. I don't know. I'm just guessing. Maybe it's let's say.
No, it doesn't say you haven't received it. I'm just saying that's where I've been sending. I thought that's where like.
Yeah, if you don't receive anything from me, you're okay.
All right, thank you.
Okay. Have a good day, everybody.